Welcome to today's YouTube presentation where we will delve into the fascinating world of muscle growth. Have you ever wondered what exactly happens to your muscles when you engage in strength training? Today, we'll explore the intricate processes that lead to muscle growth and the underlying mechanisms that drive this incredible phenomenon. So, let's jump right in. The basics of muscle growth. Muscle growth, scientifically known as muscle hypertrophy, refers to the increase in the size and strength of skeletal muscles. It occurs as a response to specific stimuli, primarily resistance training exercises. When muscles are subjected to progressive overload, they undergo a series of physiological changes that ultimately lead to muscle growth. Muscle fiber types. Before we dive deeper, let's briefly discuss muscle fiber types. There are two main types of muscle fibers: slow twitch, type 1, and fast twitch, type 2. Slow twitch fibers are more fatigue resistant and are primarily used in endurance activities. Fast twitch fibers, on the other hand, are responsible for generating high levels of force but fatigue more quickly. Understanding these fibers is crucial for comprehending muscle growth. Hypertrophy mechanisms. Muscle growth occurs through two primary mechanisms: myofibrillar hypertrophy and sarcoplasmic hypertrophy. A. Myofibrillar hypertrophy. Myofibrillar hypertrophy involves an increase in the size and number of myofibrils, which are the contractile units of muscle fibers. When you engage in strength training, the stress placed on your muscles triggers microscopic damage to the myofibrils. In response, the body repairs and rebuilds the damaged fibers, making them stronger and thicker. This process involves the activation of satellite cells, which fuse to the damaged fibers and promote their growth. B. Sarcoplasmic hypertrophy. Sarcoplasmic hypertrophy primarily involves the enlargement of the sarcoplasm, the fluid and energy stores within muscle fibers. This type of hypertrophy leads to an increase in muscle volume but does not necessarily enhance strength to the same extent as myofibrillar hypertrophy. Sarcoplasmic hypertrophy is more common in bodybuilding-style workouts that focus on higher repetitions and lighter loads. Protein synthesis and muscle growth. Protein synthesis is a crucial process in muscle growth. Resistance training stimulates the synthesis of new proteins in muscle fibers, leading to muscle repair and growth. This occurs through the activation of anabolic signaling pathways, including the mammalian target of rapamycin complex 1, mTORC1. Adequate protein intake is essential to provide the necessary building blocks for protein synthesis. Hormonal influence. Hormones play a vital role in muscle growth. Testosterone, growth hormone, and insulin like growth factor 1, IGF-1, are key hormones involved in stimulating muscle hypertrophy. These hormones increase protein synthesis rates, enhance satellite cell activity, and promote overall muscle growth. However, it's important to note that muscle growth can occur even in the absence of extraordinarily high hormone levels. Progressive overload and adaptation. To promote muscle growth, it is crucial to incorporate the principle of progressive overload into your training routine. Progressive overload involves gradually increasing the intensity, volume, or difficulty of your workouts over time. By continually challenging your muscles, you create a stimulus that triggers adaptation, leading to further muscle growth. And there you have it, an in-depth exploration of the intricate processes that drive muscle growth. Remember, muscle growth is not an overnight phenomenon but rather a gradual and continuous journey. Through the right combination of resistance training, proper nutrition, and adequate rest, you can unlock your body's remarkable potential for muscle growth. So, stay consistent, keep pushing your limits, and watch your muscles transform before your eyes.